All right, so we're going to look at section 2.5, which is on solving compound inequalities. So when you think compound, right? Compound means it's like two things. So we're going to look at inequalities where we have two in the same problem. And there's different kinds of inequalities you could have. Okay? You could have a compound inequality with the word and. You could have a compound inequality with the word or. If it has and, it's called a conjunction. And just like in English, and is a conjunction.
On your notes, guys, you're going to fill in the first blank will be compound inequality. Then you have another blank below that has some space, right? So before the parentheses, you're going to write the word and then in the parentheses, write the word conjunction. In that last blank in that section, you would write or. Then in the parentheses, you want to write disjunction. It's not so much, we're not going to quiz you guys on the names or test you guys on the names or anything, but it's still good to know them.
So just an example of a conjunction in real life might be something like, let's say you get a discount if you're between the ages of, I don't know, 6 and 18. So to get the child discount, you have to be between ages 6 and 18. So you have to be older than 6 and younger than 18. You have to be both. So you got to be somewhere in the middle, right? If you were 20, well, that's older than 6, but is it younger than 18? No. So you have to be both.
In that range.
An example of a disjunction. So that's something that would have the word or. So that could be an example like if I gave you a choice and said something like, well, you can either have no homework, on Friday or no homework on Thursday. So it's like it could be one or the other kind of thing. So you pick one or the other. It doesn't matter which one. It could be either one, right? So when we get into disjunctions, we'll see disjunctions mean you can really pick either one. It doesn't matter which one you pick. And is usually always a between. Okay? That's kind of how it works. So, and when you're thinking of it as an inequality, it's where things overlap. Right? So let's say this isn't the example where you have to be between 6 and 18. This is like between 2 and 5. So it says x is greater than or equal to 2. So now I want you to think of a number that's greater than or equal to 2 and less than 5. Okay, it has to be in both of those. So let's just make a number line here. So we've got 0, 1, 2, 3, 4, 5. So let's start with x is greater than or equal to 2. What kind of circle would I put on 2? Yep, closed. And what I'm going to do is I'm just going to put an arrow, not all the way yet. I'm just indicating that I'm going to be shading to the right. But I didn't draw it all the way because it's going to stop somewhere. It's not going to go past a certain number. Okay. So now let's look at the other part. X is less than 5. What kind of circle would I put on 5? Joe, what kind of circle would we put on 5?
An open circle.
An open circle. And which way would you shade there?
You shade to the left.
You'd shade to the left. Right. So if I shade to the left. So the black arrow is going to be shading right. The red arrow is shading left. What we're kind of looking for is where they would overlap. All right? So just watch me do this part. I'm going to show you the overlap, but I just want you to watch me for a second without you drawing it. Right? There's your black arrow. Right? It would go that way. Your red arrow would go this way. We're looking for where the black and the red overlap. Where is that?
In between.
In between. That's why when we sketch it, we do it like that. We just draw this black arrow, red arrow, and then I'm going to shade everything in between. So now it doesn't even look like there's an arrow there. Okay, you just shade everything in between. Does everyone see why that's the overlap? Because the black arrow went right, the red arrow went left. They both were in this section. If you go outside the circles, it doesn't work. Like the red arrow was never in that section, and the black arrow never went in that section. Okay, only shade where they both are. That's an
You
and.
guys usually on your notes there, it's where it says to graph. Usually with these guys, they're gonna be this to connect the dots. You'll have one dot, you know, everything. That's why we put on there. Make sure you pay attention to your signs. It's gonna be open. It's gonna be closed. But usually with these, with an and, with a conjunction, usually it's just to connect. Usually just connect the dots. In most cases, I don't think we really give you anything when there's no solution or anything like that.
Right, now for an or, that's a little different. It's basically the opposite of this. We shaded between. An or is everything outside. All right, so for an or, let's look at how that works. We're going to shade in outside the circles. Okay, the lines usually point in opposite directions.
So for your first blank there, it says the graph of inequality. First blank, you gotta write shape, you write everything. Then where it says to graph, you'll write plot the dots. So put them on your graph. Again, pay attention to your signs. And then your lines with the or usually go opposite. Because usually one answer, usually it's gonna be one answer that works.
All right, so let's start with each one of these. We'll start with the one on the left. What kind of circle would I put on 3? Ellie?
A closed circle?
How come?
Because it's less than?
All right, I agree. It is less than, but
Supposed to be closed?
it's not closed. Jacob?
Open.
Yep, it's open. Whenever you don't have the little line under it, it's open. So open circle on 3. And which way am I going to shade? Look at the inequality map.
To the left.
To the left. It says x is less than 3. So we're going to shade everything to the left. Okay. Notice this time what's going to happen is the arrows are going to basically be going in opposite directions. Let's do the other one. X is greater than or equal to 6. What kind of circle on that one?
That would be a closed circle.
That's a closed circle.
And we're going to the right.
And we're shading to the right. So what we're saying here is you can pick any number as long as it's less than 3. Or, I'll give you another option, you can pick a number greater than or equal to 6. Either one. Okay? So, or usually goes in opposite directions, and goes between.
Wait, sorry, can you repeat that?
So, and is when you connect the dots, you go between, or usually it's pointing in opposite directions.
So you get the concept.
What's that?
No, they just take it off.
Yeah. Okay, so that's basically how you graph an and and an or. That's pretty much how they look. I think we're going to get into, Mr. Wright, we get into writing the and as a
Yes.
combined.
That's next.
Okay, so when you have this, there's no way to shorten that. Okay, if you want to write down a disjunction, a problem with or, you have to write that whole thing. But when you have a conjunction, a problem with and, there's a shorter way to write that. It means exactly the same thing. I just have to write less stuff. Okay, so we're going to show you the shorter way to write.
Short, meaning you don't have to write the word or. You don't have to write the word and. You only have to write the variable once.
Okay, so again, and is a conjunction. Here's an example of a conjunction. X is greater than -1.
Now,
So
in your notes, you have that blank, so you just write that conjunction in on there.
and X is less than 4. So what happens when we write it the short way is the word and disappears. It's kind of like the and becomes invisible. Right? It's kind of like when you have x here. There's no number in front of x, but what do we always know is there and it's invisible?
1.
A 1. Okay, it's the same idea. It's there, but it's like it's invisible. So here's how you can take this and shorten it. All right. So step 1, you put the variable in the middle. So I'm going to write my answer right here. I'd have space down below too. No. Right. So put the variable in the middle. And you start with that. Next, put the smaller number on the left. Put the bigger number on the right. So I'm going to look at my numbers. What's smaller, -1 or 4? Yeah? Yeah, a negative number is always smaller than a positive, right? So put the smaller number on the left. Put the bigger number on the right. Now, what's going to go in these 2 spots that I still have a little space is some inequality symbols. Well, as long as you put the smaller number on the left and the bigger number on the right, both of our inequality symbols should point to the left. The only question is going to be, do you put the little line under it? Well, if my original problem doesn't have the little line under it, neither is this. If the original problem had the little line under it, then your answer is going to have the little line. So just go back and look at the original symbols. Do the original symbols have the line under them? No. No. So both inequality symbols should point to the left, no line. So what I just put in that box is exactly the same thing that's on that line. It means exactly the same thing. And the way you read it is you actually read it exactly the way it's written here. You start in the middle and you pronounce it x is greater than -1. That's that part. I just want to kind of highlight it so you can see it. Let's see if I can go like this. That part in yellow is the part right here. X is greater than -1. Notice what happened? The variable, the number kind of flipped around, but it's pointing at the -1. It's pointing at the -1. It's the same thing. All right. When you write it short, though, that's what's going to happen. So there's the first part. Here's the second part. X is less than 4. And then right there, x is less than 4. So notice that the x is both. Right? It's in both. It's in the yellow and it's in the blue. Right? So x is greater than -1, and it's invisible. You have to just say and x is less than 4. All right. You can only do this when you have a problem with the word and. You can't do it with an or. Can't do it. All right. So we'll try another one of those just to make sure you guys are good at shortening them up. If a problem doesn't say how to write your answer, we're fine if you write it either way. It's just if it's a multiple choice question and you get what's on the line, but they write it the short way, you might have to understand what you wrote and what they have is the same thing. All right. So let's try, do we have another example of that, Mr. Ray?
No, Mr. Hager.
All right, let's just try one. X is greater than, somebody give me a number.
12.
We'll do greater than or equal to 12. And x is less than, somebody give me another number.
7.
That's a tough one.
6.
I can't get a number that's greater than 12 and less than 6.
5.
No.
Oh.
That's like saying, I want you to give me more than $12, but I also want you to give me less than $6.
20.
There we go, that works. So now we're going to pick a number greater than or equal to 12, but it has to be less than 20. So if I wanted to combine that into a single statement, what's my first step?
Want to write it without the and.
Yep.
Put the variable in the middle.
Put the variable in the middle. Yep. Second step. Yep.
Smaller number on the left.
Smaller number on the left.
Bigger number.
Bigger number on the right. And third step. Yep.
Both sides both point to the.
They both should point to the left. How about the symbol between the x and the 12? Line under it or no line?
Yeah, line.
Line, yep. How about the symbol between the x and the 20? Line under it or no line? No line. There you go. And if you're looking at it, x greater than or equal to 12, pointing at the 12. That's that part right there. Greater than or equal to 12, pointing at the 12. And then x is less than 20. X is less than 20. All right, so it just takes those two, combines them into one. Okay. Any question on that? Okay, so it says write each sentence as an inequality and graph it. All right, so this is actually one we could practice.
Yeah, I was gonna say, guys, if you read that sentence, is that gonna be one that you could write without the word and or?
No.
What type of problem did we say? What's the word you can get rid of? And. So this has and in it. This is the type of problem you can write it without the word and. If it was an or, I don't know if we have one right here. Less than 0 or. You cannot rewrite that without getting rid of the word or. You've got to keep the word or in there. All right. There's no short way to write it. All right. So let's start just kind of identifying our two inequalities. What word is going to go between them? We already said it. In A? And. And. So we're going to have and our variable is going to be x. So we might as well set up a spot for both inequalities. Now we just have to write each one. X is greater than -8, less than or equal to 4. Those are going to be my two inequalities. How would I do the first one? X is greater than -8. Yusuf?
You just put like the sign.
Yep, which way would it point?
It would point to the right.
It would point to the right. X is greater than -8. Now if you say, whoa, wait a minute, didn't we just say the inequality symbols have to point to the left? Yeah, they do, if you're going to shorten it without the word and. We haven't done that yet. So what we have right here is kind of like what you had right here. We're not there yet. Okay, so we've got the first one. And x is less than or equal to 4. So you've got to put your x again. Okay, if you're not writing it the short way, you got to put the x twice. Less than or equal. Which way does that symbol point? To the left? Line under it or no line? Line. Less than or equal to 4. Okay, so there's your inequality. Let's just practice combining it. Step 1 to combine it. Ellie?
Do we subtract 4 from both sides?
No, there's no arithmetic when you combine it. No adding, subtracting, multiplying, or dividing. Step 1 is
Put the variable in the middle.
put the variable in the middle. Yep. Step 2. Yeah, well, go ahead.
The lesser number on the left
Lesser number on the left. Yep.
and the greater one on the right.
Bigger one on the right. Now decide your symbols. Okay. We already know they're going to point which way? To the left. They always point towards the smaller number. Between the x and the -8, should there be a line under the symbol? No, there's no line in the original. How about between the x and the 4? Should there be a line under it? Yep, because there's a line under it there. Both of these answers are correct. The top one is the long way. The bottom one is the short way. Okay, now we're going to graph it. We got to go pretty far. We got to go from -8 to +4. So you could go by 2s. You could go by 4s. Let's just go by 4s. -8, -4, 0, 4, 8. Just numbered it like that. All right. So we know we're going to have circles on -8. We're going to have a circle on 4. We just have to decide the kind of circle. Bethany, what kind of circle am I going to put on -8?
Open.
Yep, open. I agree. What kind of circle am I going to put on +4? Well, Natasha? Closed, yep. And now this is an and problem. So where do we shade for and? Is that when we connect, or is that when we have arrows in opposite directions? Yep.
That's when we connect.
That's when we connect. Yep. So we're going to connect it. Just like that. That's it. That's your answer. So is -8 part of the answer here? What do you think? How about Garrett? Is -8 part of the answer here?
Yeah.
Yeah? All right. Anyone else have any thoughts? Yes or no? Like, what does all this stuff mean that we just did? What is all this? Yeah.
No, because it cannot be -8 because it's greater than -8.
Right. It says whatever you pick has to be bigger than -8. It doesn't say it can be equal to -8. So if you were asked, is -8 part of the solution here? No, it's not. All right. -7.9, -7, -6, -5, -4, all the way up to +4. Any number in this section is a solution. How about 4? Is 4 part of the solution here? Yes. Why? I thought the number on the end here wasn't, but why is the number on the end here part of it?
Less than 40.
Right, it's because it's got that little symbol. It can be less than or it can equal 4. So that's different.
You guys, another way to think of it is, if it's open, it doesn't include the answer. If it's closed, it can be included in the answer.
Alright, so let's do this one and then see what happens. So it says that number y is less than 0 or greater than 2. Now, if this was an and, that would be impossible, right? If I said to you, I want you to think a number in your head that's less than 0, so it's going to be smaller than 0, and greater than 2. You can't do that. How can you think of a number that's less than 0 and bigger than 2? What?
It doesn't make sense.
It doesn't make sense. So if this was an and problem, we couldn't do it. But it's
Guys, the example you have, just change it and write this one in. So your example B, just cross it out and put this one. Not sure.
That is what example B is. Oh.
So guys, the one you have on there, just cross it out and put it on there.
so because if it was an and, it wouldn't make any sense, but it's an or, so that's okay. If I said to you, all right, give me a number that's less than 0, or give me a number that's bigger than 2. You could do that. All right. So what's the letter we're going to use here? We're not using X this time.
Why?
Y. So let's start with the first one. Y is less than 0. How would I write that? Basically, just tell me which way the inequality would point. To the left. Y is less than 0. Now, what should I write next? Yep. Or. You got to put the word or. So y is less than 0. Or, what's going to go right after the word or? Like the very first thing that I write. Yep. Something before that. Y. We got to put the y again. So y is less than 0, or, and now we put the greater than symbol, which points which way, Matt? To the right. And what's y greater than? 2. There you go. So when we put our circles, what kind of circles are we going to use for this one? Both of them are going to be open on which numbers? 0 and 2. So for this one, you could number it by 1s or 2s. It doesn't really matter.
So it would be okay if they just put those two numbers, like 0 and 2, and left a little space in between and drew their arrows?
Like leave a space like that?
Yeah.
Yeah, that's fine.
Or if they did like, they had like -4 and whatever, 6, they put like -4 on the left and 6 on the right. A little bit of space in between.
Well, yeah, as long as it's,
If you have something like that, maybe put a 0 in the middle so we can see.
yeah, if it's -4 and 6, though, they wouldn't be equidistant from 0.
Yeah.
One would have to be further than the other.
Yeah.
Yeah. All right, so we got 0, 1, 2. We already said open circle. Open circle. The first one says less than 0. So which way would I shade for that? Left. So we shade left. And for 2, we're going to shade everything greater than 2, which is right. So you could pick any number that's in the green section, and it would be a solution to this problem. What's that? So 1?
No, I'm just listening.
Okay. 1 would be a number that's not.
Yeah, that's what I'm saying.
Yeah. 1, 1.5, 1.7, 1.9, -0.5, things like that. Anything that's in this section right here, the section that we didn't shade in, that's not a solution. Okay. All right. Any question on that one? So yeah, when you're numbering your number line, there's lots of ways you can do it. So like if you had, the story I mentioned, like -4 and 6, you could put 0 in the middle, and then it would already be drawn for you with the tick marks, but you could put 4 here, and you could put -6 here, if you go by 2s. Yeah. As long as you go by 2s, don't go something like this. I see some people go like, you can't number a number line like that. What's wrong with that?
There's not being very consistent.
Yeah, we're not consistent. We said, okay, from the first one to the second one, that's 2 units. But then the same space is now 1 unit. So what happened? Why was it 2 and then it went down to 1 and then 1? And then I see some people go back up to like that and they do 6. It's not very consistent. So just be consistent, however you number it.
Okay, so now we're going to take everything we've done up until now, we've graphed it, but you haven't had to solve. We just gave it to you, it's already, X was already by itself, you just could graph it. So now we're just going to take it, we'll kind of take it into what we did yesterday, what we did last week, stuff like that. Alright, so let me ask you first, is this inequality going to be a conjunction or a disjunction? Conjunction, why, Chris? It has the word and, right? In this one, in example B, you'll see we'll give you one where it's set up with the word and is not written there. So we'll give you one of each. One with and written, one with and not written. Alright? So, for this, guys, I know it seems like a lot. But what I always say is, when we're doing these, treat each inequality as separate. Solve this one separately, solve this one separately. Alright? They're not they're not combined. Right? The only time I'm going to worry about them really being combined is when we graph. So this is 2 separate inequalities that you're going to solve. You're not like minusing x on this one and go over here and minus x. You treat them both separately. Because some people get wrapped up in that like, I can't, there's too much stuff. Right? Each one is separate. Right? This one's separate from this. Once we get to the end, when we graph them, then we'll kind of combine them together a little bit. Alright? So for that first one, x is already, I guess, isolated, meaning that there's nothing attached to it. So for this inequality, how many steps am I going to have? How many steps am I going to have? Someone raise their hand and tell me. How many steps will I have to solve that first inequality? 5 plus x is greater than -6. PG? I'm going to have just the one, right? Again, I want to get x by itself. Alright, it's already, there's nothing attached to it, right? So that means, because there's nothing attached to it, which step am I not going to have to do? Because there's no number attached to it. What step will I have to do? At the end. Savannah? I'm not going to have to divide because there's nothing attached to it, alright? So with this, for this first one, the first inequality in this problem is only going to be 1 step. Paige, what's that one step more to me? Subtract 5. I'm going to subtract 5 from 5 and subtract 5 from where else, Paige? A negative 6, right. Now, Paige, I'm combining negatives, right? Do they become positive? No, right? They stay negative, and what's my answer? What's my number going to be? 11. Good, you're right. Good. Now, let me ask somebody else. Do I flip the sign? Do I flip the sign? But I used the negative. I didn't divide by a negative. Again, some people are saying, well, we know that. Some people still get caught in that trick. You're subtracting. You're not multiplying divided by a negative. You don't have to flip the sign. This cancels out. Bring my x down and bring my sign down. That one is done. So you've done one of 3 parts of this problem. There's 3 parts. Solve this one. Solve that one. Graph it. Part 1, part 2, part 3 is graphing. Alright? So the next one has a number attached to the x. That means at the end, I'm going to have to divide. Alright? But first off, I want to get this isolated. Meaning nothing on that side of the sign with it. Yusuf?
Minus 5.
Minus 5, right? Minus 5 from 5, minus 5, where else, Yusuf?
Out of 20.
Again, whatever you do on one side, you do on the other. Just like solving an equation. I did nothing with the 3x. I'm just bringing it down. I did nothing with the sign. I'm just bringing it down. 20 minus 5 is what? 15. So this step here, I didn't have to do in the last inequality. Nathan, what's my last step here? Divide by what number?
3.
3. Do I have to flip the sign, Nathan?
No.
No, when do I flip the sign?
When it's a negative.
When I multiply, divide by a negative. Cancels out, leaves me with x. Again, my sign this comes down, I don't need to flip it. Nathan, 15 divided by 3?
5.
5. Make sure now when you get to the end, it's up to you. You can rewrite both inequalities if you want. You can just put the word and in between them, or like I said, you can you can do either or. Alright? You can just know that the word and's in between them, or you can write it out again in one, so you have one nice statement all kind of on the same level. Go down to my graph. So for this, right? Again, guys, I don't want you to get too wrapped up in how to like set up your number line on the test. Alright, the number line's already going to be numbered for you. So I don't want you to get too wrapped up in how like, oh my God, how am I going to like number my number line? It's not a huge deal. Because like I said, on the test, it's going to be numbered for you. This is not the skill that Mr. Hager and I are looking to see that you can do. We're looking to see that you understand which way the arrows go. If it's an and, they're going to be connect the dots. If they're or opposite directions. We're not super concerned about you guys being able to like set up your number line. We're not looking at that skill. We'll go 0, 3, 6, 9, 12. We'll go -3, -6, -9, -12. Now I know that I know 11 and 5 aren't on there. That's okay. We'll get somewhere in that vicinity. All right. So and again, you don't have to set it up. You don't have to write it without the word and. If we're just having you do it like this, leave it like this. You don't have to convert it. But if it's an and you got to graph it, what's one thing you need to know? What's probably the most important thing you need to know about graphing an and? Say it, Yusuf?
Like a shading in the middle.
The shading in the middle, right? Remember, when it's an and, connect the dots. Like it says in your notes. When you have an and, you want to connect the dots. Right? And when it's an or, chances are they go in opposite directions. Alright, so someone tell me where I'm going to put one dot. And what type of dot it is. Matt?
It's like more towards like the middle, or not really like the middle, but more towards 12.
More towards 12, that's fine. Open or closed?
Open.
Open. Now I know it's an and, all right? So again, like I said, it'll be a connect, sorry, should be -11. Fix that now. All right, so there's my open dot, at -11. Where's my other dot gonna be?
In between 3 and 6,
In between 3 and 6, right? So that's right smack dab in the middle.
and it's gonna be closed.
All right, and it's gonna be what?
Closed. Wait, no. It'll be open
When is it closed?
when it's a negative.
And then all I gotta do now is, because it's an and, just connect my dots. Remember, it's an and, just connect your dots. So this is again, we've done the skill of being able to graph it. And again, on Thursday and Friday on the test, you guys need to know when it's open and when it's closed. All right, we're not going back and, again, we're not gonna put that on your reference sheet. If that's something you want to add, so you have a hard time remembering when it's open and closed, you can put your signs on there, and then how you would shape your circles. All right. So like I told you, there'll be one. We just did one with an and. Here's one written without. All right. Here's one written without the word and. All right. Now you're probably saying like, whoa, I got a lot of stuff going on here. All right. So I'll give you guys a second to get that written down on your notes. And actually, when it's like this, in terms of solving it, it's actually quicker. I used to say, guys, I used to do this like a couple of years ago. What I used to make the kids do was I used to make them split it. I used to make them write it out as an and. But again, this when it's written like this, it's actually quicker to solve. All right. So like Mr. Hager said, he just typed in, the goal is to get x alone in the middle. All right, so we want to get the x, usually we want to get x alone on like the left-hand side. But because of the way this one is written, it's in the middle, we want to get it alone there. Remember, like we said, when we write it without the word and, we want the variable in the middle. Number on one side, number on the other. All right, so like you're saying, if you do something to the middle, do it on the left and right. So I want to get this in the middle by itself. What's in the middle with that 2x? Gigi?
Positive 1.
Positive 1. So what am I going to do?
Subtract 1.
Subtract. Like Mr. Hager said, what's one number I'm going to subtract 1 from? What's one number in this problem? Gigi, give me 1. 9. Brady, where else am I going to subtract 1? If I do it, again, we subtract, and Mr. Hager just said, we want to get x alone in the middle. If you do something in the middle, which I did, -1, I want to do it on the right.
-3.
I also want to subtract it from -3. Good. So that's really the only new thing there. When it's written like this, when you have x in the middle with 2 inequality signs, when it's written as a conjunction without the word and, you got to do, whatever you do in the middle, do on both outsides. All right? I didn't use 2x. I'm just bringing it down. I didn't use this sign. I didn't use that sign. I'm just bringing them both down. Garrett, -3 and -1?
Oh, -4.
-4. Good. 9 minus 1. Catherine, 9 minus 1? 8. Cool. Again, the goal is to do what again?
Get the x in.
Get the x alone. So right now, Bethany, what's preventing me from getting the x alone right now? Has a 2 attached, right? How do I get rid of that 2? Divide by 2. Now think about this. Same rules apply, like Mr. Hager wrote here. Whatever we do in the middle, we do on the left and on the right. So what else? What else do I have to divide by 2? Gigi, what's one place?
8.
By the 8. Nicole, what's the other place? By the -4. All right? I'm going to get -2 here. 4 divided by -4 divided by a +2, a -2. Bring my sign down. Again, this cancels out, leaves me with x. And then positive 8 divided by a positive 2 is a positive 4. Alright? Now, again, we know it's an and. Don't get wrapped up in the direction that the arrows are pointing. Alright? You know it's an and. So it's an and. When it's an and, what do we have to do? With the dots, what do we have to do?
Oh, put the variable in the middle.
We already have that. I'm just saying to graph it, none of it.
Put the smaller number in the left and the larger number in the right.
Yeah. And again, we have that, which is good.
Yeah.
Alright?
Okay.
Wait, what do you want to go on? That one's gonna be one more. To graph it. What should that graph look like? Arrows going opposite or arrows going
the same direction.
Yeah. Again, don't get so wrapped up. You know the word and is not written there. Just connect the dots. That's all it is. That's all you have to do. I know it looks kind of weird, but when it's like this. All you want to do there is connect the dots. I'm going to go by 2's. 0, 2, 4, 6. Negative 2, negative 4, negative 6. Alright, so let me give you one number where I have to put a dot and what kind of dot it's going to be, what kind of circle it's going to be. How about Alex? Where am I going to put one dot? Negative 2, open or closed? Open. My other dot's going to go where, Miguel? 4. There they are. 2 open circles because there's no line underneath. Again, the word and's not written there, but because we know that's another way we can do it. It's an and problem. This is another way we can do it, and just connect the dots. That's all we have to do. Don't get too wrapped up in the way it looks like this. Again, just connect the dots. But like Doug makes a good point, just make sure that your smaller number is on the left. If you want to add that, make sure smaller. So just make sure. Again, it may not set up that way. That's okay. Just flip-flop it. If like negative 2 was here and 4 was here, just switch the spots. The signs are going in the same direction. That's fine. Just switch spots.
If we switch the numbers, the signs we have to flip to.
Yes. So just make sure you flip your signs too. All right. This one, guys, same deal. It's 2 separate inequalities. All right. So I'm just going to solve them separately. The only time I'm really going to think of them as connected is at the end when I have to graph them. All right. So again, we'll treat it as 2 separate inequalities. We're not going to worry about connecting them, or we have to graph them. All right. So don't think of like when you have the word and or to separate it. Don't think of it as you have to. Whatever you do on this one, you're going to do on this one, and vice versa. They're 2 separate inequalities. All right. So for my first one, right? 2x minus 5 less than negative 1. Miguel, what do I want to get by itself?
Redo the first side.
Say that again.
Redo that.
So out of these 3 things, the 2x, the negative 5, the negative 1, what do I want to get by itself?
I want to get the x by itself.
X by itself. All right. So what do I do first?
Add 5.
Add 5 to both sides. Again, that cancels out. Bring the 2x down. Someone tell me negative 1 plus 5? 4. Now this one, I just have one more step. Dylan, what's that step? What's the last step in this one? Divide by 2. Whole reason I did it was to get x by itself. It just cancels out. I didn't divide or multiply by a negative. My sign stays the same. 4 divided by 2, 2. I'm going to take the word or. I'm just going to bring it down. That way when I solve this one, they'll all be on the same level. All right? Same type of thing here, right? The only thing is my sign's different. Everything else is the same. All right? I want to get the 3x by itself. So Bethany, in order to get that 3x by itself on one side, what do we have to do? Minus 8. Minus 8. Minus 8. Bethany, 9 minus 8. 9 minus 8. You have $9, you spent 8. How much do you have left? 1. And then I'm just going to bring the 2 down. You can think of it that way too. Alright? My sign doesn't flip. I bring the 3x down. Just like I did over here. My last step is to divide. I'll divide by 3. X. 7. So again, let me say it again. I know I sound like a broken record, but we're treating these two things separately. We're not worried. Now we can graph them. So it's an OR, right? So usually with ORs, what are you going to tell me, Mary?
Why did you flip? Oh wait, never mind. I wrote it wrong.
I did okay?
Yep, I wrote it wrong.
I didn't screw up. So Mr. Hager did the graph by 2s, which is fine. And again, we don't need any negative numbers because both are positive. All right? Someone give me my first thought. Ellie?
An open circle on 2.
Open circle of 2. Which way is my arrow going to go?
To the right. And to the left.
And whatever direction the arrow hits, think of it as an arrowhead, right? It's pointing this way. That means my line has to go that way. How about Melanie, my other circle?
An open circle on 7.
Alright, so where would 7 be? No, it's not written on the chart.
In between 6 and 8.
In between 6 and 8. Open. What direction? Melanie, right or left?
Right.
Right, so it's pointing that way. Again, it's an OR. So that's fine, right? ORs, again, they go ORs opposite. ORs go opposite. Ands, you want to get the overlap.
Right, so take a look at our last example. So example 4, this is a word problem. And it says the temperature range for copper soldering is usually between 350 and 550 degrees. Write an inequality to represent this. So I'm pretty sure that's what it is. Again, 350 to 550, I'm kind of estimating a little bit. But on Friday, I'm going to be actually taking a class where I learn more about these different kinds of temperatures and different things you do with soldering and brazing. So when you're working with these materials, there's different temperatures, because if you go too hot, right, when you're dealing with copper, you could actually melt copper pipe. You don't want to melt the pipe. You're just trying to solder 2 pieces together. So you got to make sure you're hot enough to melt the solder, but not too hot where you actually melt the whole pipe. That's no good. So they just want us to write an inequality to represent this. So whenever we have an inequality, we always have numbers in it. But what's the other thing we also have in the inequality somewhere? An x or some kind of variable that represents the temperature. So let's let x represent our temperature. All right. So I'm just going to write that off to the side. X will be our variable, and it's going to represent the temperature. Okay. So we want the temperature to be, it says between. What word do we usually use with inequalities when we want between? Is that an and, or is that an or? Savannah? That's an and. Good. So we're going to have 2 inequalities, right? We have a minimum temperature that we have to be at, and then we also have a maximum temperature. It says we have to be between 350 and 550. So let's start with the lower temperature. How would we write our inequality on the left? X has to be what to 350 degrees? What inequality am I looking for?
Less than or equal to?
We want to be cooler than 350?
Oh no, so it'd be greater than.
Yeah, exactly. Right? We have to be between 350 and 550 degrees. So we want to be greater than or equal to 350. And can anyone give me my other inequality to represent the maximum temperature? Nicole? And what do we want to put? Less than or equal to 550. Anything else I need there to make that an inequality? Yeah, I'm going to put my x in. There you go. There's your inequality. Okay, just because we got a couple minutes just to practice combining it. If we wanted to put that into one statement without the word and, how would we do it? Put the x in the middle. I like that. Yep. the lower temperature on the left, higher temperature on the right. Which way, Nathan, which way do my inequality symbols point? Yep, exactly. Always point to the left. Are they going to have the equal to's under them or no equal to's?
Yeah.
Yep, they're going to have the equal to's. So either answer is correct. Right. So our temperature is greater than or equal to 350 degrees and less than or equal to 550. Okay. Any questions on that? All right, so just a couple quick reminders about the rest of the week. So homework tonight, it's going to be a worksheet on 2.5. Don't forget, this is the last academic week. So if there's any tests we got to make up, homework, want to make sure we try to wrap that up by Friday. Last day of new material will be tomorrow. So Thursday, we're going to start the test during the first half of class. Friday, we're going to finish it because we have the half day on Friday. Reference sheet, we got it up early on Google Classroom, so that way you guys can, plenty of time if you need to print it at school, if your printer doesn't work at home, it's already there so you can print it. And then the periods on the half day are 1, 3, 5, 7. So make sure you just keep that sheet out. You still got about 6, 7 minutes. We'll have you guys practice a couple problems.
Out of the problems we have left, I'll make you do one. And then guys, also keep in mind, tomorrow's lesson is not, I looked at it yesterday, it's not super long. So we'll have some time to do some review tomorrow as well.